Hello my dear champions, welcome back to our channel Karnataka. Today I'm here to again start and teach you a very important session for your preparation of second PUC and KCET, and that's going to be inverse trigonometric function. So remember in the previous live that I was conducting, one of you mentioned that, sir, can you give me a video? If I watch that, if I follow that, I will be able to clear my concepts, my PYQs, my problems for CET and PU both. Okay, so for that you can refer this particular class of ITF one shot at one place, getting everything to be prepared from. Right now, I want to give you more information about this particular platform that we are providing you, because since it is just introduced to all of you, I want to show you what are the benefits and how to access this platform. First of all, this platform is available for every student who are studying from us on YouTube for free. Okay, basically we are not charging even 1 rupee for this. So what is this platform? This is basically all-in-one platform where you because when you're learning on YouTube, there can be many distractions. There are different video recommendations. There are something, you are watching a lecture, things get difficult, and you watch something else. You go and get some, start watching a scrolling shorts or whatever it is, right? So there are many distractions over here. Basically, it is difficult to find the classroom experience on YouTube. For, let's say, some of students can already find that we have taught them for years now, but for an average student it is difficult to find the classroom experience, that level of personalization on the YouTube, right? So for that we have created this platform to benefit all of you, to benefit all the serious learners. Okay, and this is what, this is your AS KCET 2027. This is the batch that we are giving you again, and this will be completely free. So this is the more information. So how do you get access to the batch? So basically, if you look at any of the videos which is going in the one shot session, okay, if you go down below, scroll over here and check the description of the video, check the description of the video, you're going to find here access the course here. And if you click on this is again the same website opens for you, the same platform opens for you, and once you are over here, you'll find this title as AS KCET 2027. Okay, this is nothing but your AIO all-in-one platform. Okay, and when you come here, you have to go for what? Buy now. If you click on buy now, you can see here it is for 1 year 100% off, 0 rupees, exactly 0 rupees, no charges over here. Click on buy now. It'll ask for your number and your region where you're from, and simply after that move on, and you'll get to access the course right away. Means you can see the platform. We have already shown you how to access the assignments, the classes and everything in the platform, right? If you might have seen my, if you look at my this video, in this only I have shown you everything how to access the platform. So go and check it out. Okay, if you already have the access, you can see the schedules over there, the past sessions conducted. So in the platform you're able to see every single thing. You're able to see every single thing. Okay, means what are the classes that has been already conducted, those recordings, you can ask doubts also over there. Okay, so a lot of features are available, and all is this available for free. So get the access to the learnings in more personalized way from our AIO platform, and you already have the link also, you'll find in this video's description also. If you're watching me on YouTube, you can do the same in the platform also. It will be basically like learning in YouTube only, but with less distraction or no distraction and more personalization that we actually aim for at Vedantu. Okay, so moving on, in this session what I'm going to talk about, let's go back to our lecture today. The lecture is about inverse trigonometric functions. So in this session, of course, this chapter has its limitations. It does not have, when you look at the concept side, a lot of things. Means you'll have formulas, you'll have the graphs, you'll have the domain and range, basically principal value and principal value branch, some properties, and mostly question solving. So I'm gonna deal with that over here. You can see I'm gonna deal with that over here only. Okay, so I think we are ready. Let's start the class with the introduction. What is it? Inverse of a function. We know that inverse of a function, because ITF is one of the case of inverse, right? Inverse trigonometric function. What is the title? Inverse trigonometric function. This is a special case of inverse functions. Yes. And when are the functions invertible? When the function is bijective. When the f is bijective, we call it to be invertible. What's the meaning of bijective, if you recall? Very simple, sir. Bijective functions are those functions which is 1, 1 and onto 1 and onto. Clearly, if you look at the function y equal to sin x, is it bijective, sir? Of course not. If you draw the graph of sin x like this on both the sides, you draw a straight line, it is simply coming as multiple intersections, which is going to be an example of many one. This is a example of many one, and that is nothing but simply giving us understanding of the function is periodic, right? It repeats after a certain period. What is the period of sine x function? Let me know in the comment section, right? So in the chat, what is the period of this particular function? Yes, let me know. Yeah, and you can see the function is periodic and function has more than one intersection for y equal to any fixed value, right? Of course, that has to be between the range of -1 to 1 only. In that case, this function becomes many one. If it is many one, means not bijective. We cannot create a inverse version of this, but it does exist. We have the inverse version, right? Y equal to sine inverse of x exists for us. It means there must be some condition to make this happen. If sine inverse exists, and looking at this we say it does not exist, means there must be something that we have to do about to making it bijective or invertible, and that is called as giving the restriction on the domain. What is this called as? Giving the restriction on the domain. So we have to make it 1 1 and on 2. What do we do that? So we have to create this restriction on domain. This is the method, the concept to make it invertible. What is the condition over here? Very important condition. What is it? Range. The range is kept same. Range cannot be changed. Range is kept same, not changed. Kept same. So if you are able to do that, then you make the function invertible. Example, sir. So initially, if you look at this, the first version, where you have y equal to sine x, let's write domain okay, of function and range of function. What do you get over here? Domain is -infinity to +infinity. My range is what? This is clear, sir. -1 to 1. What is the graph? This is +infinity. This right here is -infinity. The graph is, and so on. The graph is, and so on. Where the upper bound is +1 and the lower bound is -1. This is the graph. Yes, we know that very well. Let's look at the other case. When I make it restricted over the domain and create this invertible form. So again, the function will be y equal to sine x only. Just this case will make the domain of the function to be restricted from -2 to +π/2. Now, why only this, sir? Why only this? Because check carefully. If you restrict it over here, right? This is the restriction, because this value is what? This value is -π/2, and this value is what? Simply π/2. If you do this, if you draw this part, if you just take a section over here, then this becomes a 1 1 part. Please check. So draw the graph of this with this restriction. Then at this point, which is π/2, you'll have the value 1, and this point, which is nothing but -π/2, I have the value -1. So can you see that range is kept same? The range of the function is kept same from -1 to 1. And keeping the range same, I have got a domain now, a new modified restricted domain in which the function is actually invertible. There's no doubt about that, right? If you draw a line anywhere, it is a 1 1 function. And since domain and codomain will also be the same, we can say here this is a 1 1. That was the problem in the previous case. So I have made this 1 1, and it was already on 2. In that case, what happens? It becomes bijective. So this is a bijective form, and this becomes invertible. This becomes invertible. Great, sir. Makes sense. This is the new form. This is what we have to remember now. I'm not saying that is wrong. Of course, this is for, if we don't talk about inverse part, then the domain of sine function is this only. If a question comes, what is domain of sine function? You will not say it is this, sir. This is only when we are talking with respect to inverse of the function. Generally, domain of the function will be what? Sine function will be what? All real number itself. Okay? Because we cannot change the domain itself. What is the meaning of inverse of the function? What is the meaning of inverse of the function? Okay, so we have learned this in relation and function already, right? So if I have a function defined f(x) to y, okay, and if I can define another function, unique function, where it is gy to x, can you see that x was domain, y was codomain or range over here, y was again same thing. If you see over here, it is altered or swapped. What is the condition? That, can you see this, gof, g of y means what? Basically gof is equal to identity function is x and fog is equal to identity function in y. If you have this condition, then the given function is called as inverse of each other. If gof becomes equal to ix and fog becomes equal to yy. So if you have not watched my previous session of relation and function one shot, please go and check it out. I've taught you what it means to be gof and fog in detail. So I'll just tell you, I'll revise this concept over here also. Gof means, so if I'm taking, let's say, gof, what I can put over here, I'll put, let's say, any value x. Why only x, sir? Because domain of f is what? From x set only, right? If I have the function defined from x to y, it means any element I'm taking x will be from which set? From the domain set x only, right? No? Correct, right? Think about it. If this is my function, let's say f, okay, and let's say this is my set x, this is set y, so if I have, let's say, over here value 1 and 1 is mapped to 2, 1 is mapped to 2, then if I take a value 1, what happens to f of 1? F of 1 becomes equal to what, sir? 2, right? So in this, what I'm going to write, if I'll write this as g of f of 2, g of, sorry, excuse me, my bad, extremely wrong, g of f of 1, right? Because I'm putting this as example over here, guys. This is nothing but an example of the mapping. So g of f of 1, so this becomes what? G of 2, g of 2. What did I say? When you're writing the function g, it becomes y to x. Means if I'm writing the another notation, another mapping like this, this was for the function, please check. Yeah. But if I write the same type of mapping for g also, you know that very well, it will become y, this will be x, because initially the mapping was x to y, this will be y to x in g. So if I take the element, will be what over here? 2. And what is the number over here? 1. If you map it back, 2 goes to 1. So g of 2 is how much? G of 2 is coming back to, we started with f of 1. So basically in this you put x equals to 1 and you're getting the final result also equal to same. What it means? What type of function is this? Take a second, take few seconds to understand this. In gof, you started taking x as 1. Why 1? Because x is from the domain of f. So I have taken the element over here. It is mapped to like that. Okay. So started with function f 1 to 2 and in g of f becomes 2 to 1. So in gof started with 1, getting back the result also as 1. What is this called as? This is called as identity function. Remember? How many of you remember this? If fx is equal to x, this is the definition of identity function. If you're thinking, sir, why you're explaining so much, why you're doing all of this, because this concept is important for your board's preparation. You have unit test coming up and you have to understand this very clearly. Okay, this unit test marks and concept will build for your midterms also. Pre-boards, without no time, you'll see in few months you'll have your very important exams coming up. So even though this is not important this is not a syllabus of this chapter, I'm still teaching this because this is important. ITF, of course, when we go to cos inverse and tan inverse, will not take much time. For sin inverse, understand all the concepts very clearly. So if you are losing patience over here that, sir, why you're teaching this function chapter again? I know it's not from here, from this chapter, but it is very important. I know all of you are not able to understand how when your teacher writes in the class, gof is ix and fog is iy, you have missed it. Okay, so you started with x, you're getting back to x, and this is nothing but your identity function as I wrote over here. So that's why we were writing I, and from which set we took? From the set x. That's why it is Ix. And what is fog? Iy. Same way, ulta will do this time. So whenever you have gof as Ix and fog as Iy, then only we can say G is inverse of F. G is equal to F inverse. This is the condition for inverse function. Okay. So basic understanding from here is that what is the summary? That definition of inverse and range and domain stops each other. Moving on. Let's do the first one. Clear. Let's do the first one. Let's do the inverse of first one. Let us do this. So what is this going to be? If I take the function, sir, y equal to sin x, we have the results now. Domain of the function will be what? I'm going for inverse, right? So minus pi by 2 to pi by 2. Let's close this. And range of the function is what? Of course, sir, we know this, minus 1 to 1. Let's draw the graph now. When I've taught you the inverse in the last class, I taught you inverse of the function means that if you take mirror image of the function about this line, this line is called as y equal to x line. If you take mirror image about y equal to x line of which function? This function, sir. Sin x was this only, remember? This was sin x. Sir, no, it was not sin x. Let me show you. Let me show you. Here, check. This is sin x only, right? Like this. If I go and write over here, same thing I've drawn. If you take the mirror image of this function about y equal to x line, how will the image look like? Check. The image is this, sir. The image is this, sir. That's my image or not? See, this represents your sin x and this represents your sin inverse of x. So any inverse function is what? Mirror image about y equal to x line. So sin x and sin inverse of x is like that. Okay. So if I have to write the sin inverse part, let me try. Y equal to sin inverse of x. Domain of the function will be what? Domain will be this value, minus 1 to 1, because it says interchanged. And range will be what? Range will be minus pi by 2 to pi by 2. Okay, this is the range of the function. How will the graph look like, the final graph? Have a look. I'll draw it separately also with the values intact. This is the graph where this value, I'll write over here. Understand this, output of any inverse trigonometric function is what? Always an angle. This will be minus pi by 2 to pi by 2. This will be minus 1 to, over here we'll have 1. Minus 1 to 1. So this is your y equal to sin inverse x, the graph. Okay, I hope this is clear. Is this clear, guys? Please check. Acha, there will be no arrow over here. You will not find an arrow like this. You will not find an arrow like this, because arrow means it is moving forward. It is not the case. You cannot have the arrow over here, because if you have the arrow, what it means? It is going up. But this is actually a terminating value. It cannot go after pi by 2. It cannot move after pi by 2. That's why it is no arrow over here. I hope it makes sense. This is the graph. This is the graph. Okay. Now, what type of function is this? Let's look at the nature of the function. This is important. Nature of the function. Nature of sin inverse of x. So, first nature is, of course, increasing nature. What it means? If you move in x-axis from left to right, move from x-axis left to right, what happens to y? It increases. It's going up. Check. If you take 1 point over here and 1 point over here, let's identify these 2 points. The respective value of y, which is bigger, this second point value is bigger. If I take this as, let's say x1 and x2, clearly sin inverse of x2 is more than, because it is on this side, this is over here. So sin inverse of x2 is more than sin inverse of x1, and this is also because x2 is more than x1. So when x2 is increased, means when you move from left to right, y is increasing. This is an increasing function. It's also an odd function. It's also a odd function. What is an odd function? Odd functions are those functions which is symmetric in origin. Symmetric in origin. Please check. So this part is same over here. This is the mirror image. Right or not? If you take in the origin, which is over here, this is the mirror image, right? So whenever you have that, it's called as odd function. Or basically, if you remember, definition is f of minus x equals to minus fx, definition of odd function. So in what happens in sine inverse case? Sine inverse of minus x is equal to minus sine inverse of x. And yes, this is important. This is important. Okay. So increasing, it's an odd function. Okay, and what is the period over here? Pi. From minus pi to pi by 2 is period is pi. Okay. Now, this information is regarding our full year batch, which is Pariksha batch. Okay, we have already started the classes from 6th July, but don't worry if you're joining it right now. If you joined few days back, all the previous classes will be given to you as recorded. Okay, what are the offerings of this batch? So very simple. Second PUC full syllabus of boards will be covered, and you'll have KCET preparation alongside for all the chapters. Okay, then you'll have for each subject, which is basically what you have: physics, chemistry, maths, and biology. For each subject, you'll have 110 plus hours, means total 110 for physics, chemistry, maths, each of them. Live classes will be available, of course, for whatever classes you already missed, because batch started on 6th of July. Okay, the fee for the batch is 3499. Again, let's get back to the offerings. You get 20 plus tests, which will be again part and full length test. Part test means for whatever chapters are covered, for that chapters you'll have the test available, and full length test will be for full syllabus covered. That will be later, of course. Okay, now the access will be all of that present till the exam of KCET. Means it will not be before, it will not be like, you know, once we have done the test, you will not have the access. Access of this batch will be available to all of you till the KCET examination. You get the class notes, assignments, unlimited DPP generator in the platform of Vedanta. So you can download the app from the Play Store and start accessing the course right away. Take it as soon as possible so that you don't have to miss many classes. Okay, I hope this is clear. Moving on. Domain and range of ITF, I hope this is clear now. So this is basically, I have already done this. Domain and range of ITF is, they are interchanged. So what happens is, once you create this restriction on the domain, this becomes your range. Example, sir, check na. Over here. This was the restriction on the domain, and this became what? The range. This became your range. So the domain restriction becomes whatever the domain you got after restriction, that becomes range, and that is also sometimes called as principal value branch. It's called as principal value branch. Principal value branch. Very important term. Okay, very important term. Sometime in the question they will not ask you range, they will simply ask you what is the PVB, what is the principal value branch of this particular function. So remember that. Okay, whenever no branch of inverse function is given or mentioned to you in the question, it means always principal value branch only. If nothing is mentioned of ITF, it means always PVB only. Okay, the same understanding, nothing else is over here. This already explained you. Increasing function, odd function, maximum value is what? Pi by 2. Minimum value is minus pi by 2. Okay, I drew the graph already for you. Cos inverse, how do you draw the cos inverse? Let me teach you this as well. So for cos inverse function, check here, we'll have to draw the cos x first. Cos x generally is not invertible. Check. This is the cos x graph. Like, if you keep going on like this, you'll have not bijective. So what you're going to do? Create restriction, guys. And how do you create restriction? Check here. So y equal to cos x. You will restrict the domain now. This is the domain where, what's the domain over here? Again, minus 2 plus infinity. For cos x also the same. But if you restrict the domain to what? 0 to pi. So why 0 to pi? Why not minus pi by 2 to pi by 2? Because range has to be kept same. Range has to be kept same. Range is also minus 1 to 1 in this case. If you do that, check here. This is your graph. 0. This is value. This is the value. At 0, what is the value? The highest value is 1 and the lowest value is minus 1. This is your graph of cos x function. The graph of cos x function. What did I teach you? Inverse means mirror image about this line. Okay, mirror image about this line. How do you do that? So of course, like this. Can you see that? This part is mirror image to this. This part here is mirror image to this. Okay. And what about this one, sir? Now check carefully. This part I'll write it for you together so that it makes sense. This is the mirror image side. This one and this one. This is the mirror image. Okay. And the other one is the green one. Okay. So if I erase this marking, it will make more clear to you. So basically, the green is my which function? Cos inverse. If I draw this separately, for y equal to cos inverse of x, the graph looks like this. The graph looks like this. This is again y, x. Domain of the function is what? As I said, whatever is range over there, this range becomes domain. What is the range of the function? 0 to pi. Check here. This value is 0. This value here is pi. This value is minus 1. This value is cos inverse of x. Now you tell me, decreasing or increasing, sir? Let's understand this concept also. If you take a function over here, let's say, excuse me, this is, let's say, my x1 value, and if I take here x2 value, clearly x2 is more than x1. X2 is on the right hand side, so more than x1. But what is this? Cross check. F of x2 is what? Somewhere over here, and f of x1 is somewhere over here. So f of x2 is less than f of x1. If you go from left to right, what is happening to the function? It's dropping down. What happens over here? It will be property, if you check nature, decreasing function. What about odd even, sir? Neither of them, neither odd nor even, because for it to be odd, symmetric about origin. For it to be even, symmetric about y-axis. It should be like this. It's not there, right? Which is not there. What happens? Neither even nor odd. That's the case. Okay, highest value is pi, lowest value is 0. I hope this is clear. Please check. Okay. Tan inverse, again we can draw this very simple. Tan inverse graph, how will I draw? So first we'll draw tan x, y equal to tan x first. How will the graph of this look like? If you just have to show you a little bit, this is the graph, right? And if you draw this, you get what? First, many one, right? What is the domain over here? In this case, right now, domain is all real numbers except for odd multiples of pi by 2. Odd multiples of pi by 2. What's the meaning of that, sir? Tan 90 is undefined. Tan 180 is 0. But tan 270 is undefined. It means at odd multiples, 90 into 1, 90 into 3, 90 into 5, 90 into minus 1, minus 3, all this way. So for all n belongs to integers, this is the domain. From all real numbers, remove the odd multiples of, because 2 into n plus 1. 2 into n is always even, plus 1 becomes odd. So odd multiples of pi by 2, if you remove, that's the domain. Okay. What about range? Range is simple over here. So range of the function over here is all real numbers. Plus minus 2 plus. This is the arrow, sorry. This is the arrow. So minus 2 plus infinity. But this is my before restriction, sir. This is the graph before restriction. What about the graph after restriction? So what is the restriction going to be? Always remember, range is kept same. So range is what? Minus 2 plus infinity. Minus 2 plus infinity, which is real number. What about domain? Domain is going to be minus pi by 2 to pi by 2. How come, sir? How come? Let me show you the graph. Draw the graph of the function. It comes like this. So if I draw the graph part, is the graph, right? This is towards plus infinity. This is towards minus infinity. Does it make sense? When it goes close to pi by 2, this goes plus infinity, and when it goes to minus pi by 2, goes to negative infinity. This is the particular graph of the function. What about your mirror image? If you draw this line y equal to x, this is the line y equal to x. This one is what? This one is tan x. Let's look at tan inverse then. Let us look at tan inverse. This is your tan inverse function, the white part. This represents your tan inverse of x. Tan inverse of, let's draw to understand this. Here we go. So function is y equal to tan inverse of x. Because sir, why is spending so much time to draw the graph? Even in the live class I did that. Okay, why I'm doing it over here also? Because this chapter, when you do the graphical part, you can get more clarity. How the graph is coming, how its domain is coming, how is range coming, why it is this way itself. All the understanding comes from here. This is my graph. This is what? Minus 2 plus infinity. This value is what? Minus pi by 2. Again, you can see it's open actually, because there's no definite value over here at pi by 2. What is my domain? Minus 2. Domain, right? Minus infinity to plus infinity. And range is what? What is it? Check here. Minus pi by 2 to pi by 2, open bracket, not closed. Open bracket. Function is increasing, decreasing. Function is increasing, decreasing. Check here, please. If I take these two values only, x1, x2. Over here, over here. So x2 is more than x1, and fx2 is, of course, more than fx1. Check here. This value is fx2, this value is fx1, so more than fx2. fx2 is more than fx1. Function is increasing in nature. First condition is increasing function. Second condition, check here. If this is my origin, this and this is symmetric. This is mirror image over here. Okay, this is mirror image over here. Actually, this is not. Okay, I wrote something over there. Where is it? Mirror image I should write. Mirror about it, not symmetric. Mirror about it. Let's do this. Mirror in origin. Mirrored in origin. Okay. Let's get back to the question at hand. So you can check over here this also. This part is image over here. Okay. So what I get in this now? Odd function. Means tan inverse of minus x is what? Minus tan inverse of x. And I forgot to write it over here. For cos function, no, this value is cos inverse of minus x is pi minus cos inverse of pi minus cos inverse of pi minus cos inverse. Okay, so graphs are done. The cot inverse again, let's not draw the graph of this, because drawing the graph of part is more important for the first three, but we have to know the graph of these. Okay, let me show you the domain and range, of course, clearly. The domain is what? All real only. Domain is all real. What about range of the function? You can see here 0 to pi, but this time will be open. 0 to pi. 0 to pi was also for cos inverse, but that was closed. Here it is open. What about odd even? Again, neither odd nor even. Means cot inverse of minus x is what? Pi minus cot inverse of x. And what about increasing, decreasing, sir? So one point is here, second point is here, and third point is it's the decreasing function. Decreasing function. You see, this is going down, right? So if you increase the x value, y is coming down. Cosec inverse again. Check here. First, let's write the domain. What is domain, sir? Domain is minus infinity to minus 1 and 1 to infinity. Open, closed, union, 1 to infinity. Starts from here, goes all the way till here, and there. What about range, sir? Minus pi by 2. What is the range, sir? Minus pi by 2 to pi by 2, except for 0. Because sine 0 is 0, so cosec 0 will be what? Undefined. So we remove that part. That's the first condition. Second one is, check here, increasing, decreasing. Increasing, decreasing is decreasing function, sir. If you go like this, it is decreasing. Also means if you move from left to right, y value comes down. Decreasing function. Decreasing function. It's decreasing, right? It's decreasing. What about odd even? So it is odd function. How come odd, sir? Mirror image about the origin. What is happening over here? Cosec inverse of minus x is minus cosec inverse of x. Second verse. Second verse. Please check. Just write domain of the function first. First thing first. What is domain over here? Minus infinity to minus 1, 1 to infinity. Same thing. Minus 1, open, close, union 1 to infinity. Yeah. Range of the function, sir, is also very clear. 0 to pi except for this value. What is this value, sir? Pi by 2. Because cos 90 is 0, so sec 90 will be undefined. So we'll go, yeah, 0 to pi, closed, remove from here, pi by 2. That's my range. Second. Increasing, decreasing, check here. If you move like this, the function is going upwards. You're also going upwards. Increasing function. Increasing. Third one, same over here also. Neither odd nor even, because it is not symmetric about this, and for it to be symmetric about what you call y-axis, the function should have been like this. Then it becomes symmetric, but it is not there. So you cannot have that. Neither even nor odd. That is for the even part, what I drew right now. So what it means? Sec inverse of minus x is pi minus sec inverse of x. Pi minus sec inverse of. Again, list of all the domain range for all 6 ITFs. Okay. Similarity you can find over here. This and this is similar. This part and this part is similar, and this part is similar. So sine inverse, cos inverse is similar, cosec inverse and sec inverse is similar, tan inverse and cot inverse is similar in the same in the domain side. For range side, this is similar, but here it is open for the tan inverse. But let's not go with there. Okay, your way to remember it. Summary of all the graphs together. Let's solve this question. Principal solution of cot inverse of minus 1 by root 3. How to solve it? Cot inverse is there means, sir, pi minus cot inverse of 1 by root 3. Special angles you should know. Pi minus this value will be when tan is root 3, that is pi by 3. Cot is 1 by root 3 when tan is root 3, that's pi by 3. It becomes 2 pi by. Answer is option A. Simple question on the application of domain, range and the special angles of trigonometric functions. Special angles of trigonometric functions. Domain of the function cos inverse, domain question. So domain of cos inverse is what? Whatever is the value over here, that value, if I call this to be y, from where to where? Minus 1 to 1. In this case, what is this? 2x minus 1. From where to where? Minus 1 to 1. Move 1 on both sides. You get minus 1 plus 1. 2x, 1 plus 1, you get 0, you get 2x, you get 2, divide 2 on both sides because it is multiplication over here. 0 by 2 is 0, x, 2 by 2 is 1, so 0 to 1, x is 0 to 1, and they are both inclusive, so the equal to signs over here. Answer is option A. A very simple question, by the way. This is the KCET PYQ, by the way. Like this question have come. So usually earlier the ITF questions were very easy, but now they are improving the quality. Okay. Also tan inverse of 3 by 4. What is this, sir? Very simple question. Very, very simple, sir. This is basically what you learnt in grade 10 only. How come we not learn that? You have learned this, no? Now tan inverse of 3 by 4 you have learnt in this year. Take tan over there, it becomes 3 by 4 equals to tan theta. Right angle triangle or not? Yes, sir. What is this? Let's say theta means this is 3, this is 4. How many of you know Pythagoras theorem? Of course, all of you. So 3, 4 and then becomes 5. I'm looking for what? Cos theta. What I'm looking for? Cos theta. This is I've taken as theta. Cos theta is what? 4 by 5. Check here. 4 by 5. Answer is option A. Why these questions? So did you do these questions in the live also? I have done this question in the live also. Because these are the questions that builds the gap between the concepts and the problem solving. Very basic ones. Of course, we have more. Don't worry, we have more questions that we'll solve in this class today. But yeah. Okay. Let's see. We have a V. It's here only, sir. Here only, sir. Moving on. Domain of fx. Domain of fx. So fx is a combination of this function, and this function. So whenever you have more than one functions taken together, okay, if you're writing the domain, you have to write domain which is true for all the three. Let's write domain of this. What is domain of this function? -1 to this function, all real numbers. For this function, okay, what it means, sir? What is the meaning of this? Let's check the meaning. -1 plus 1. This is what? Minus infinity, and this is plus infinity. Now let's check the first function. It says enclose both of this between them. The second one says all of it. Second one says all of it, and the third one is very beautiful. It says enclose this, go this way, enclose this, go this way. What I said, intersection of all. Intersection of all. If you take the middle part, this is not there. If you take this side or that side, then sin x is not giving me anything. Sin inverse of x is not giving me anything. Means I have only one situation over here, which is this particular line and this particular line. What is this line? This is nothing but x equals to -1. This is x equals to 1. It means in this case, my domain of the function f is what? -1 and 1. Is it between all -1 and 1? No, only -1 and 1. And that we write in terms of middle brackets. My answer is option B. Answer is option B. Okay. Now, I hope this is clear, right? This is clear. So, properties of ITF. Properties of ITF. Sin inverse of sin x is equal to x. Cos inverse of cos x is equal to x. So on. Cosec inverse of cosec x is equal to x. But is it always? No, sir. Only when this is true. What is this called as? Principal value branch for sin inverse, cos inverse, tan inverse, or domain of sin x, cos x, tan x, cot x. What domain? The domain which is coming after restriction. Check here. Domain of sin x is what, sir? All real number. Is it given as all real number? So what was the domain which made it invertible? That domain you're going to take, not all the domain. Listen to me again. Domain where it is true is the domain after restriction, or that is simply called as principal value branch of the inverse functions. So either you call restricted domain of sin x, cos x, tan x, cot x, sec x and cosec x over here, or you call principal value branch for these values, these functions, for the ITFs. Makes sense? Only in that x, the inverse is giving me x. If I had an angle x over here, it is, let's say, pi. Sin inverse of sin pi is not pi. Not there. Okay. So please make a note of this. Next. Negative argument properties, already taught you this. What happens when you remove x by minus x? So this is for odd functions, tan inverse of minus x is minus tan inverse of x, and so on, is for neither odd nor even. It is not even, neither odd nor even. Okay. Reciprocal and complementary identities, important ones. Okay. So if I get sine inverse of 1 by x equal to cosec inverse of x, does it make sense to all of you? No. Let's try to prove this. Sine inverse of 1 by x, you're saying, sir, is equals to cosec inverse of x. That's all we have to prove. How? If I take this as some angle theta, continue, sine inverse of 1 by x is equals to theta. Move over here, I get 1 by x equals to sine theta. Acha, I hope you know that what is the meaning of moving actually. We don't actually move sine inverse over there. What it means is you take sine on both sides. I might show it like this, but it means is taking sine on both sides. Both sides. Okay? Taking sine on both sides. When you do that, it becomes sine of sine inverse, and that is going to be simply 1 by x, because you can check over here. The condition is noted. So this is for 1, no. Yeah, that means the angle will be what? Minus pi by 2 to pi by 2, because it is for what? This means minus 1 to 1. No, this is for cosec side. So cosec side. Yeah. So it is 1 by x actually over here. X is defined for cosec, not for sine inverse. That's why it is the domain of cosec inverse, not the domain of sine inverse. I hope this is clear. So 1 by x sine theta. So let's do one thing, bring over here and bring this over there. It becomes 1 by sine theta equals to x. What is 1 by sine theta? That is cosec theta equal to x. I want to find the value of theta, right? Because I've taken this value as theta. I've taken this as theta, assumption. So it becomes what? X equals to theta equals to cosec inverse of x. Check here, theta is equal to this also and this also. This was assumption and this is the proof. We got that. Clear, right? Yes, makes sense. What about this one? This is for reciprocal relation. This is for complementary relation. Whenever you have sine inverse of x plus cos inverse of x is pi by 2, tan inverse, cot inverse, sec inverse, cosec inverse. How come, sir? Let's try to take tan inverse and cot inverse over here. Just saying, prove that tan inverse of x plus cot inverse of x is pi by 2. How come, sir? How would you prove this? How would you prove this? Let's take. So if I, let's say, write this as, okay, if I, let's say, I write this as, first of all, I hope you know that this is nothing but your angle and angle. Correct? This is nothing but your angle and angle. Okay. So in this case, let's try and writing this as tan inverse of x equals to pi by 2. Take this as theta. Pi by 2 minus theta. Pi by 2 minus theta. Can I transform it like this? Yes, sir, I can. Move tan inverse over here. It becomes x is equals to, what is it? Tan of pi by 2 minus theta. Clear or not? Clear. Tan of 90 minus theta is what? Cot theta. Achha, this is the, guys, this is the proof for explanation, not for the proof of derivation. I'm trying to give you, hint how to do it. What is the concept behind it? Okay. This is not the derivation side. Concept behind it. Okay. For derivation, stick to NCERT only. For board related things, NCERT derivations is what you need to do, because it's a step marking. Okay. And there's a process that you have to be followed. If you want me to do that only, let me know that in the comment section. Because over here I'm giving you, can you see that flow? This is not how you derive. Do derive like this in your board examinations? You do not do that. Okay. If you want me to do that, let me know. I want to see many comments saying that, sir, do in the way NCERT does. Exactly. Then I'll follow that method. Because what I'm doing over here is giving you understanding what is the logic behind it. What is the approach for the question? Why we are doing what we are doing. That's what I'm giving you over here. When you do that, it becomes cot theta, and theta was taken as cot inverse of x. It will also become x. You can see the clarification from here. If you want me to, again I'm repeating it, if you want me to especially do the derivations of any particular question for NCERT side, for board's purpose exactly, let me know that in the comment section. I want to see more participation in that thing, then only I'll do that. Otherwise, telling you for proofs, you have to follow NCERT derivations only. Otherwise, you lose marks. I'm clearly telling right away. Okay. Again, sum and difference of tan inverse. The properties are here. The formulas here. Let's check. Tan inverse of x plus tan inverse of y is given by tan inverse of x plus y upon 1 minus xy. Okay. This is, if you remember, this is nothing but the formula of, if I take this as angle A, let's say, and this is angle B, A and B, and move this tan inverse over here. Again, it's not moving actually, it's taking tan on both sides. It will become simply tan A, tan B, 1 minus tan A, tan B. Anybody able to remember that formula? Because if tan inverse of x is A means what? Tan of A is x. So I'll have here tan A, tan B, 1 minus tan A, tan B. So if you know the formula in terms of trigonometric function, inverse will be very easy for you. This is the condition when xy is less than 1. Xy is less than 1. For xy which is more than 1, we have 5 plus tan inverse of x plus y. So over here there is a priority actually. This is important. Okay. This is important. And this also is important. This very rarely asked. Very rare. So first and the last is the most important ones, and sometimes this also is there. Even in boards I've seen very less questions on this. In CET they can ask. Okay. So the important formulas over here will be first, second, and but this so the first, second, and the last. This very rarely asked. Frankly, I've not seen any question in the board's book or your PYQ side on this property. Okay, makes sense. All right. So few more formulas. Double angle formulas again. Remember double angle formulas for your trigonometric functions. So double angle formulas, triple angle formulas. What are the important ones over here? Tan inverse in terms of tan inverse is important. Tan inverse in terms of sin inverse, cos inverse are very important. These 5 are very, very important formulas. All these 5. But double angle formula are the ones which are usually asked. Triple angles are rarely asked, but there has been a question on this side. Okay, triple angle formulas are rarely asked, but yeah, they do ask that also. Rarely, but yes. In this, so this has been asked in CET also and PU2 also, second PUC also. This one. This has been asked in CET and second PUC also. PYQs I'm talking about. Okay, so they have not asked directly this. They have asked sometime they'll give you the proof. They'll ask you to pick the option for the domain. Remember that question 0 to 1 by 2, 1 by root 2. That one condition. When you had cos inverse over here, for sin inverse we had minus 1 by root 2 to 1 by root 2. Remember that condition? Okay. So yes, this is clear. The formulas are clear. Okay. And also the conversion between inverse functions. Okay, this is very vital actually in some of the problems where substitution is required, whether it is a question of KCET, whether it is a question of boards, or it may be a question from calculus also. So conversions helps a lot. Okay, so how can you convert sin inverse in terms of directly tan inverse, cos inverse to tan inverse, sin inverse, and so on. Okay, so basically the conversions among the 6 inverse trigonometric function is very, very important. Again, you don't have to remember this. If you can, good, it will be faster in KCET. Otherwise, the triangle will hold true. For example, if I take sin inverse of x, output as an angle theta, then this is theta for the right angle triangle, sin inverse of x is there, means this will be x, this is 1. So by Pythagoras theorem, this becomes 1 square minus x square. So 1 minus x square. You can check from here only. You'll get tan theta as what? X upon this. So x upon this. Cos inverse, you're going to be getting what? This upon 1. Okay. So you can simply use the Pythagoras theorem in the right angle triangle to get the conversion, or you can remember the conversions to take that leap of solving the question faster. Okay. So this was it from the concept side. Let's look at some questions just for practice, and then we'll move on to what your PYQs of, or the board pattern question and KCET pattern question. Okay, because I remember last class you guys asked me, sir, can you provide a session in which you cover the theory, you cover the BU2 board style question, you cover the CT style question. So this is that particular session. Just make sure that not only on YouTube, if you're watching on the YouTube, please make sure that you are taking advantage of the Platform provided to you for a personalized learning at AIO, all in one option. Link you will find. Basically, what is it? It's like a batch, okay, like a paid batch, which is coming for free, okay, and it is given for the link for that. You'll find it over there. That join the batch, join the course. You'll go and check the link in the video description. If you're watching me on the YouTube, check on the link over there. And on that link, you will have to simply enroll for free. Once you do that, you can start the learning right away without any distraction, with more personalization. Okay. Second was sec square of tan inverse of 2 cosec square of cot inverse of 3. Check this value. Sec square is what? 1 plus tan square of tan inverse of 2. And what is cosec square? 1 plus cot square of cot inverse of 3. Okay. Cot square of cot inverse of 3. Please let me know the answer in the comment section. What is the answer going to be? Simply it will become 2 square and 3 square. So I'm going to give the final answer up to you to give me the result. Okay, I've given you the hint and solution of this question. Okay, next. This is the value of sine inverse of cos of sine inverse of minus root 3 by 2. Start from here. If you know the special angles, that's good enough for you. Sine inverse of negative value becomes minus sine inverse of root 3 by 2. This is nothing but, check, this becomes minus pi by 3. Minus pi by 3, because sine inverse of root 3 by 2 is pi by 3. There's a minus sign outside. Put this bracket. Now what do we have outside? Cos. So right here, cos. Cos of minus 60 is in fourth quadrant. Cos is positive, so it remains positive 1 by 2. Now on this, you have what outside? Sine inverse. Apply sine inverse. This answer going to be what? Pi by 6. 30 degrees. Pi by 6. That's my option. Okay. Moving on. Let's look at some board style questions also. Starting from here, this is the board style question. This is the value branch. Is very favorite question of your boards. In last 10 years, maybe more than 5 to 6 times they have asked this question. Every alternate year, they ask an MCQ or a 1 marker based upon this. This is the value branch of cot inverse is what? We know that very well. It will be 0 to pi, right? It will be just in this case open 0 to, right? Because if you look at the graph of cot inverse, plot you this. This is the graph of cot inverse. So it starts from where? This is 0 and this is pi. Domain is all real number, and this is how it goes. It's not very perfect, but I have to get the point. This is how it looks actually. Let me erase and 1 second. I can do better. So let's try to do that better. This is the graph basically. This is the graph of cot inverse from 0 to pi. Both of them are tending to, because they cannot reach the value negative or plus infinity. What is the domain? Minus infinity to plus infinity. Graph of cot inverse of. See, if you remember the graph, you don't have any confusion. You can of course remember the domain and range also, but graph certainly helps with the clarity part. This is the board style question. Okay. Principal value of cosec inverse of minus root 2, also a board style question. We have this as odd function. So minus cosec inverse of root 2 is going to be pi by 4. So minus pi by, that's my option number. Since you know now in your boards 20 questions is compulsory for the MCQ side. So we have more MCQs, and this chapter they ask one MCQ. Okay. This type of also question comes where you have more than one functions and looking to find the principal value branch across all of them. Tan inverse of 1, this we know very well, pi by 4. Cos inverse of minus 1 by 2. For this we have a formula, pi minus, remember, pi minus cos inverse of 1 by 2. What about this? This will be simply minus sine inverse of 1 by 2. I hope you can see how I'm applying the formulas. Okay, moving on. Pi by 4 plus pi, this is nothing but pi by 3, this is nothing but pi by, what is it? 6. Pi by 6. Check this combination, very important. What is this, sir? 180, right? This value right here is 180. What is this? 60. What is this? 30. 180 minus 60, 30. 180 minus 90. How much is that? 90. That's nothing but pi by 2. So why didn't you teach in terms of pi by 2 only, radians only? Because why will we calculate it? Use the logic. That's more than enough. It's an MCQ anyway. So what we're getting, pi by 4 plus this result, that is coming as pi by 2. LCM is 4 pi plus 2 pi, so 3 pi by B. So again, specifically board related. But sometimes what happens, no, you'll not believe it. In KCET, if you look at the PYQs, I'll show you right away after we are done with the board's question. There will be, at many occasions, you'll find questions of CET also similar to what is there in boards. So there should be no confusion regarding that, especially in the chapter which is a little bit on the easier side, for example, of matrices, of ITF, of relation and function. You might find similarity in the question of CET and boards. How come, sir? Because if you look at the 60 questions that comes in KCET Maths, okay, in the KCET Maths, at least 15 to 20 is clearly easy question. Means 15 odd marks you can easily score. Easy question. That is of board, very directly applied. Basically what it means is to be easy. This means, bacha, that direct application of the concepts in NCERT. Direct application means formula based, definition based, domain range based questions will be there. And such chapters are ITF. You have probability also, sometimes you have relation and function, matrices, so determinant also of questions can be in this category, especially of PU1 chapters. Okay, and again 20 plus 25 plus questions are moderate, and last 15 will be your difficult one. So 15s are difficult, rest all is easy and moderate only. For that reason, you'll find many questions of ITF which are identical in CET and boards. So we have to be, we should not be surprised or questioning the teacher that, sir, this is a very board level question. How come you are asking or explaining this in the CET side? Because it can be the case. Okay, let's move on to this. This is again board style only. Sine of pi by 3 minus sine inverse of minus 1 by 2. Okay, so we'll go with pi by 3 over here. It will become, of course, plus, we know that because you'll get the minus sign outside, the odd function. Sine inverse of 1 by 2 is how much? Pi by 6. Outside we have sine 60 plus 30, 90, and sine 90 is how much? 1. And 90 is 1. Option D. What is it? 60 plus 30 is 90, sine 90 is 1. So that easy? Yeah, that easy. The chapter itself is not difficult. Only for certain questions of ITF where you have identities involved, then it becomes a little tricky. But only if you don't know the formulas of ITF that I've already given you in the class. So download the notes and simply learn from there. The value of tan inverse of 2 cos 2 sine inverse of 1 by 2. Okay, have a look. Start from here right away. 2 times of sine inverse of 1 by 2 is how much? Pi by 6. Isosceles angles. So I am getting as pi by 3. This is just for this part. What is outside? Cos. Apply here. Cos. What is cos pi by 3? Continue the flow. Cos 60 is again back with 1 by 2. Cos 60 is 1 by 2. And what is the outside then? 2 over here. If you bring this 2 back, how come this 2 coming here? From here. This 2 and 2 cancels. What is the result now? 1. What is this, sir? Tan inverse. Pi by 4. Option number. Option is the fourth one. So what is this flow? Simply understanding how to crack it up. Okay. Backwards we'll work around. Next. This is the value of sine inverse of sine 3 pi by 5. Now this is a good question. This type of question also comes in CET as well. Okay, sine inverse of sine of 3 pi by 5. Okay, so this situation is there if you have what? If you have principal value branch involved. What is the principal value branch? This is it. Minus 5 by 2 to 5 by 2. If you have that, then it becomes what? Simply 3 pi by 5. Because you will think, sir, tan inverse of sine theta is theta. So whatever is the angle, option A is there, tick and done. My answer is option A. Wrong. 3 pi by 5 is outside the pi by 2. Check. You'll get it. Okay. Now, so how do I solve this in that case? You have to make in the form what we have. So what we're going to do in that? Rewrite this angle. What we'll do? Rewrite that angle. So pi minus 2 pi by 5. Pi minus 2 pi by 5. Why I'm writing like this? Because check here. Pi minus 2 pi by 5 is what? The LCM is 5. Pi into 1. So this is 1 actually, 1 into 5. So pi into 5. 5 pi minus 2 pi. That's 3 pi by 5. So basically 3 pi by 5 is nothing but pi minus 2 pi by 5. So I'm writing this value again, rewriting this value again in this form. Why? You'll see. Sine of pi minus theta. Sine of pi minus theta. Hope you remember. Sine of pi minus theta. Which quadrant, sir? Second quadrant. Second quadrant sign is positive. So equal to sine theta. Equals to sine theta. Sine of 2 pi by 5. Sine inverse. Now 2 pi by 5 is between or present in the principal value branch, okay, in the range. So you check this out, the answer becomes simply 2 pi by 5. So for all of the students who remember sine inverse of sine theta is theta, gets the answer is option A and your answer is wrong. But if you remember that sine inverse of sine theta in the principal value branch is theta, then you will get it right and answer becomes option C. Think about it. If you were writing an exam which is with negative marking, just assume for a second. I know I'm not saying KCET is for negative marking. There's no negative marking in KCET. Let's get that part clear first. But if you were writing an exam which was having negative marking, so just by remembering this formula, sine inverse of sine theta is theta. If you remember only this part, and you pick answer A, concept is right. You pick answer A, not only you lose marks in that question, you actually get negative marks awarded to you if you choose option A. So for students of JEE or anybody who's preparing for any exam which has negative marking, please understand this. Just knowing this is not sufficient. Sine inverse of sine theta is theta when theta is in the principal value. Clear? I know you might find me that old guy who always keeps asking you to focus on a particular thing, but that's how it is. If you don't do that, you lose marks. Cot inverse of 1 upon x square. Now think about it. If I have outside cot inverse, this is the basically range we are writing. Why we are writing that? I'll show you that also. Don't worry. So I have to make the bracket inside also in terms of cot. Correct, na? If outside we have cot inverse, now to simplify this any further, I need to make inside of the bracket in terms of cot. Agreed, sir. How do you do that? Simply take x as sec theta. How come, sir? Because sec square minus 1. So how will I remember? Yes, there are certain forms, 1 plus x square if you are able to find out. It has to be always in terms of tan. If you find x square minus 1, it's always in terms of sec square or cosec square. If you find 1 minus x square, please remember, if you have x square minus 1, in this case x is either sec theta or cosec theta. If you have the form 1 plus x square, x is cot theta or tan theta. If you have 1 minus x square, x is either sin theta or cos theta. This is the substitution available for trigonometric functions, because these all are related with what? Identities. If you take in this case x as sec theta, sec square minus theta is x square minus 1. What is this? Sec square theta minus 1. Apply the root, guys. Sec square minus 1 is tan square. Root, guys. So tan theta. check. This is 1 upon that. This is 1 upon that. It becomes cot inverse of 1 upon tan theta. That is nothing but cot inverse of cot theta. Answer is theta. If x is secant theta, it means theta is secant inverse of. Answer is option C. Then I told you, I'll tell you honestly why we are taking mod of x more than 1, because if you remember a domain of sec, you're taking x for what? Secant theta, no? The domain of sec inverse is what? Domain of sec inverse is what? But you forgot. You didn't forget? Check here. Domain of sec inverse. It's minus infinity to minus 1 and 1 to infinity. You have to remember that, sir. Sec inverse. Domain. All are except for minus 1 and 1. What is that? That's what it means? I'll write it for you. Minus infinity to minus 1, open, closed union, 1 to infinity. And this can be written as what? Simply all mod x more than, when equal is okay. But why can't we write equal over there? Anybody can tell? This is actually over here, mod of x greater than or equal to 1. This is correct. But in the question that we were doing, we did not write that. Anybody can tell why? Can you try to think, sir, it is not a live class, how will we tell and you will know? But try to think, put your mind on work. Can you see over here? What I said right now, mod of x is more than equal to 1. But the question is saying only more than 1. Why not equal to? Why not equal to? Obvious, sir. If you take equal to, it becomes undefined. 1 square minus 1 is undefined. Getting it now? That's why it is. Just this. So this is there because of the presence of x as sec theta. So if anybody was good with domain, just by looking at this domain, you will be able to pick the answer as either C or D, sir. And you know very well, this will give me tan in denominator, right? This domain gives me answer either as C or D. Why not D? Because if you take cosec part over here, it will become cot in denominator, right? But you want cot in numerator. Here, cot inverse of cot theta you want. You don't want cot inverse of 1 by cot theta. You don't want that. So basically, this cannot be there. So option C. If this was a CET question, and you need to solve this question within 10 seconds, first think, domain, because of this, I have either option C or D. A or D is gone. Because A and B, what is the domain? Domain of A and B is what? All real numbers. So looking at domain means option C and D has to be there. Why not D? Because if you take D, you will get cot in denominator, but I want in numerator. Cot inverse of cot is in numerator. So that's why option is C. 10 seconds. Yes, sir. So in CET especially, not all the tricks are well known, proven results. Some of the tricks are conceptual learnings that you build while you're learning something. Does it make sense? Moving on. Next question. Solve the equation tan inverse of this. Now, if you don't know the formula, how would you solve it? Did I teach you this formula today? Yes, I have. Here's the formula for this. What is that? Tan inverse of 1 minus tan inverse of x. Remember teaching this formula? Yes, sir. Over here, it becomes half tan inverse of x plus tan inverse of x. Over here we have tan inverse of 1 actually, that becomes pi by 4, right? Becomes 3 by 2 tan inverse of x, that's pi by 4. We can cancel this. 2 to the 4 and bring 3 over here, right? That becomes pi by 2 into 3, that's 6 tan inverse of x. Where is tan inverse of x? Pi by 6. Then x is 1 by 3. X is 1 by 3. Clear? Moving on. Again, board style question only. Tan inverse of cos x minus sin x upon cos x plus sin x. This kind of question also can be simplified in the form of CET, or rewritten in the form of CET. can give you options and choose from there, but I'll show you that also. But let's understand this question right now. What is the condition? Outside is tan inverse, sir. Inside should also be tan or tan, basically tan, not tan inverse, tan. Okay. How do you get tan? Divide everything, numerator and denominator, by cos theta, by cos theta. Okay. I'll have 1 sin by cos will be tan theta, sorry, not theta, no? X is there, right? Cos of x, tan of x. 1 minus tan x, 1 plus tan x. What is the formula for this? Can you remember? Yes, sir. Tan of pi by 4 minus, just since I'm teaching you today, so I will be little bit more helpful. I'm writing every single step. 1 is tan pi by 4. This will be again same thing. 1 as it is now. For this, we'll write plus sign. What is multiplied to this number? Tan x. I can multiply 1 also, right? If nothing is multiplied, multiply 1. Okay, sir. So, tan x, and this 1 becomes what? Tan pi by 4. Now, this is a formula. What formula is this? Tan of, what formula is this? Anybody recalls? This formula is, sir, tan of A minus B. Tan of A minus B. So this is the simplification of the bracket inside. What do we have outside, guys? Outside we have tan inverse. Tan inverse of tan is the angle itself. So pi by 4 minus x. There has been a question in continuity differentiability where they ask you derivative of this function y. Answer will be what? If you've learnt it, minus 1. Okay. Moving on. I'll just have a look one more time. Achha, my request to all of you, for whoever is writing CET, please remember this formula. This is equal to, always remember this formula. It will be much time saving for you guys. Tan of pi by 4 minus x is 1 minus tan x upon 1 plus tan x, and tan of pi by 4 plus x is what? 1 plus tan x upon 1 minus tan x. Now this one, this is a board PYQ only. Cos inverse of 4 by 3 plus cos inverse of 12 by 13, cos inverse of 33 by 65. Very difficult, right? Not at all. Take this as angle A, this angle as B. Why angle? Output of inverse function. Angle only. Good. From here, what I get? Cos inverse of 4 by 5 is A. Am I moving it? Not moving. I'm actually applying cos on both sides, but just for the sake of it, I show you like this. What is the actual mathematical operation over here? Taking cos on both sides. So this is cos of A, right angle triangle. This is the angle A. Cos means this is 4, this is 5, this is 3. Pythagoras theorem. Pythagoras theorem. Let's go with the B now. Same way we'll have cos of B equal to 12 by 13. This is angle B. This is 12. This is 13. Pythagoras theorem 5. 144 plus 25 is 169. Root of that is 13. Pythagoras triplet actually. What I want? Sine of B. That will be 5 by 13. Did I write that? No. Sine of A. That will be 3 by 5. Once you have that, what is the output on the right hand side? Check here. Cos inverse. So if you want cos inverse, take cos of A plus B. Because this side we have A plus B. If you take cos of A plus B, you will get that side cos inverse after simplification. Let's look at the simplification of this. Yeah. What I get for this formula is that cos A cos B minus sin A and sin B. Cos A plus B is cos A cos B minus sin A sin B. Okay, as it is cos of a plus b cos a cos b. That's 4 by 5 into 12 by 13 minus 3 by 5 into 5 by 13. Continue please. 48 by 65 minus 15 by 35. 8 minus 5 is 3. 4 minus 1 is 3. 33 by 65 is coming as cos of a plus b. This cos goes over here. So a plus b is equal to cos inverse of 33 by 65. That's proven. That is proven. Please check. Now, since I have taken all the steps, you can refer over here. I hope this makes sense. Now, these are your KCET questions. So, we have done a different variety of problems that comes from inverse trigonometric function in the 1 marker, 2 marker or 3 marker for boards. If you look at boards syllabus of second PUC, only 1 marker, 2 marker and 3 marker have come in the past. Every year if you check the blueprint, that's what has been asked. Okay, so I have done of the different category. The previous one was a 3 mark. Now, moving to, what is it? As I said, some of the questions are very much favorite of your KEA, that is principal value branch or domain range problems. The first question is on that only. Range of second verse, if you know it, answer is very clear, option. No need to solve. No need to. Okay. The first question is pretty clear from the. Achha, this is all KCET PYQs, by the way. This is all KCET PYQs. Okay. Next, this also is a PTPYQ from 2019 paper. Sin inverse of 3 by 4, cos inverse of 3 by 4. What is it going to be? Looks difficult? Not really, actually. We have two types of sin inverse over here. Can you separate them? Yes, I can, sir. So sin inverse of 3 by 4 plus cos inverse of 3 by 4. This is together. But we have two sin inverse. So right here again, sin inverse of 3 by 4. Now it makes sense. This two value is what? Is the result for trigonometric identities, sorry, complementary identities, right? From that you get what? Let's say this is an angle, right? Sin inverse of 3 by 4 is an angle. Take this as theta. What I'm getting over here, pi by 2 plus theta, or theta plus pi by 2. Outside we have cos right here. Continue. So cos of basically pi by 2 plus cos of 90 plus theta is, sir, minus sine. Second quadrant, cos is negative. Minus sine. What is theta? Sine inverse of 3 by 4. Sine of sine inverse. Value itself, so minus 3 by. Any shortcut way to solve this question? Any trick to solve this question? Will it take this longer to solve? Not really. In your mind, you can solve this question in your mind only. Okay. You can see this is making a pi by 2. You'll have plus sine 3 by 4. Cos 90 plus theta will make sine. And there's a minus sign because of the second quadrant. You get the answer quickly. Okay. And you get it in your mind also. How come, sir? With practice, of course. A plus pi by 2, and this is same concept. Check here, we have 2 tan inverse over here, right? This 3 cot inverse as 2 cot inverse of x plus cot inverse of x. We can do that. 2 tan inverse plus 2 cot inverse. How much is that? I don't know, sir. Take 2 common and write here tan inverse of x plus cot inverse of x. I'm taking 2 common from the first 2 terms, and this is as it is. This cot inverse of x as it is, and it lies between b to a plus pi by 2. This over here, this bracket is what? Pi by 2. So 2 times of pi by 2 plus cot inverse of x is between b and a plus pi. B and a plus pi. This 2 and 2 will cancel. I'm getting over here pi plus cot inverse of x is between b to a plus. This is my result to compare. Let's put this as result number 1. What is the result number 2? Check here. Cot inverse of x range is what? 0 to 5. 0 to 5. Open. Do we have cot inverse here? No, sir. We have pi actually. Pi plus cot inverse. So add pi on both sides. Add pi everywhere. Here also you add pi. Here also you add pi. And here also you add pi. Do that. You'll have here. You'll have over here what? Pi less than pi plus cot inverse x less than pi plus pi, that is 2 pi. This is my second result. Check. Compare this pi plus cot inverse, pi plus cot inverse. This is then 2 pi and b. It means what? B value is 2 pi and a plus pi by 2 is pi. A plus pi by 2 is equals to pi. So a equal to what? Pi by 2. A equal to what? Pi by 2. Please check. My answer is a is pi by 2, b is 2 pi. So option C is correct. The domain of the function defined by cos inverse of root of x minus 1. So cos inverse has a condition, root has a condition. We'll take both. Let's take cos inverse condition. Okay, let's take condition for root first. X minus 1 has to be more than or equal to 0. Inside the root, value has to be positive. Excuse me. X should be more than 1. Till what? More than 1, good. But till what? 2, 3, 4, whatever it is. If I put 2, put x as 2. 2 minus 1. Root of 1, that is correct. Let's take more than 2. Let's say x as 2.5. Then x minus 1 will be what? 1.5. Take root of x minus 1. It will become, this will be what? More than, root of 1 is 1. Any value after that will be having root bigger than that. Yes. Root of 1 is 1. We take root of 1.1 or 1.2 or 1.5, whatever you take, that will be more than 1. But cos inverse does not have more than 1 values inside the domain. Cos inverse domain is what? Minus 1 to 1. It means I can take x more than 1 but less than or equal to 2. I cannot take after 2. What is my answer? 1 to 2, both inclusive, that is option number. Option number makes sense. Okay. Cos of cot inverse of minus root 3 plus pi by 6. Please check. Cot inverse of minus root 3 plus pi by 6. Okay. Acha guys, I know this is not a live class, this is a recorded one. But if you are able to solve the questions, let me know how many of you are getting, like how many questions you got it right. At least say you got out of what right, you got 5 correct, 6 correct. Okay, because I am solving at the last of board style and this close to 21 problems. Let me know out of 21 questions that I did right now, I'm going to do right now, how many of them you got it correct. Okay, so cos of cot inverse of minus root 3. So cot inverse of minus root 3 is what? From here you check first. Pi minus cot inverse of root 3 plus pi by 6. This value is what? Pi by 6 plus pi by 6. Cancel, just pi. Outside we have cos, that's minus 1. Can you get a question easier than this? And it is not very far, 6 years back. 2020. 2000? Right? Okay. Now this one. 2021 PYQ of KCET. Tan inverse of 1 by root 3 sin of 5 pi by 2. Sin of 5 pi by 2. Where is it? Plus or minus? This is pi by 2. That's 3 pi by 2. This is the 4 pi by 2. This will be what? Again back with 5 pi by 2. Sin 5 pi by 2. Positive, right? Positive only. This value is how much? 1. This is 1 by root 3. Have over here tan inverse. Sin inverse of root 3 by 2. So pi by 3. Outside we have cos. Okay. And this we have with sin inverse multiplied. Tan inverse of 1 by root 3 is pi by 6. Sin inverse of cos of pi by 3. Cos pi by 3 is how much? Cos pi by 3 is cos pi by 3 is 1 by 2. So again pi by 6 on the first. Sin inverse of 1 by 2 is also pi by 6. Answer is pi square by 36, which is option number B. Pi square by 36. Clear, right? This one simple question, by the way. Domain of cos inverse of GIF of x, greatest integer function of x. Domain of that. Think about it. How will the graph look like, sir, of this function? So here, sir, closed, here open, here closed, here open, here closed, here open, closed, open, closed, I mean. This is, sir, how much? Minus 2, minus 1, 0, 1. Sir, minus 1, minus 2. This is, sir, 1, 2, and 1, 2, and check carefully. It says cos inverse of, it means cos inverse of, let's say, y. We know that y will be lying from where to where? Minus 1 to 1. That's the domain. So the GIF of x, if I write what I get from here, basically I get that y is equals to this. So for GIF of x, what is the output going to be? This is the value y. Function is y equal to this. I want that to lie from where to where? Minus 1 to 1. Since I want from minus 1 to 1 means this value. Minus 1 here, 1 here. In that, I can get minus 1 from where? Check. I can get minus 1 right from this point, which is minus 1. At x equals to minus 1, what is the value? Check here. Minus 1. And I can get 1, which is this value, all the way till this point. Value of 2 is what? 2, sorry, but you said 1. Check. What if I take 1.999? That's 1, sir. So right before 2, I am getting 1. So at 2 it is 2, but before 2 it is 1. So my answer for x is what? Minus 1 to 2. This is the value. Minus 1 to 2. So x belongs to what actually? Minus 1 closed to 2 open. When x is between minus 1 to 2, this y, for this x, this value which is nothing but y, will be what? Between minus 1 to 1. What is my answer? Minus 1 closed, 2 open. Minus 1 closed, 2 open. The clarity must be there. GIF of x and the domain of cos inverse. Moving on. This question, okay, a very good problem, little bit calculative in nature, but if you remember the forms, it becomes faster. Okay, so 1 minus sin x, what form is this? 1 minus sin x is nothing but cos square x by 2 plus sin square x by 2. This is for 1, this whole thing is for 1, and minus sin x is nothing but 2 sin x by 2 and cos x by 2. This and this part is same. Let's grab this understanding. 1 is what, sir? Cos square plus sin square is 1, the identity number 1. And sin x is the half angle formula using over here, 2 sin x by 2 and cos x by 2. Now check carefully. I am getting basically over here 1 minus sin x equals to a square b square 2ab. I'll repeat, a square b square minus 2ab. A square b square minus 2ab. Something we have seen, sir. A minus b the whole square. A minus b the whole square. Apply root, please. In the question, there is a root. This becomes cos of x by 2 minus sin of x by 2. Because root and square will cancel. This is for minus. What about when we have 1 plus sign? So write here plus sign. So if you write here plus sign, this will become plus, because sin x is negative, now it is positive, means this will be positive. This will be positive. It will be here. Check. 1 second. Now check. So we have, if you look carefully, root of 1 minus sin x means cos x by 2 minus sin x by 2. Cos x by 2 minus sin x by 2. That's the first part. Plus 1 plus sin x. So cos x by 2 plus sin x by 2. The plus sign, cos x by 2 plus sin x. Same thing is there, but with the minus sign in between. Same thing is there, but with the minus sign in between. Let's try that. Same thing is there. Cos x by 2 minus sin x by 2 with a minus sign in between. So sin cancels. Here cos cancels. Because plus cos minus cos will be cancelled over here. What we have? Cos x by 2 plus cos x by 2 is how much? 2 cos x by 2. Minus sin and minus sin becomes what? Minus 2 sin. So 2 and 2 cancels. We are getting here cos by sin. So cot x by 2 with a minus sign. With a minus sign. Now you check the final result over here only. So outside we have, sir, cot inverse. This is coming from where? From the next page. Cot x by 2. Here the formula for this? Yes. Pi minus cot inverse of cot x by 2. Pi minus x by 2. Sir, so many steps. How will we solve this question in examination, by the way? Good question. Again, you have to remember something here also. Whenever you're getting 1 plus sin x or 1 minus sin x, remember the form, it is always cos x by 2 and sin x by 2 with a plus minus sign. Then this is how many steps. But even if you don't know anything, how many steps are there? 1, 2, 3, 4, 5. Even if you do from scratch, 5 steps. But if you don't do from scratch, if you remember some of the statements, 2 steps maximum. And yes, it can be solved within 20 to 30 seconds. Moving on. Sin inverse of x by root 2, 1 minus x square upon root 2 minus sin inverse of x. See here, we have here sin inverse of x. 5 minus x by 2, I forgot to mention. Okay, see. Here. We have sine inverse of x. We have x over here also. Let's write this as theta. Sine inverse of x as theta. It means sine theta is x. So we'll have 1 minus x square as 1 minus sine square theta. So 1 minus x square in the root will be this. This value becomes what? Cos square theta in the root. That's nothing but cos theta. If you know the form, I have taught you right now, today itself in this session, the conversion between the various inverse trigonometric function. But if you don't know, this is also done. Cos theta is 1 minus x square. Now check this out. The big bracket I'm talking about. Start from sine inverse only. Sine inverse. So x is what? Sine theta. I have into 1 by root 2. Where, sir? X upon root 2 is into 1 by root 2. Take that as cos pi by 4. Cos 45 is how much? 1 by root 2. Plus 1 minus x square is how much in the root? Cos theta. So write that. Cos theta. And again we have 1 by root 2. So sine pi by 4. This is nothing but minus theta. Minus theta. Sine inverse of sine of theta plus pi by 4 minus theta. Sine of sine is nothing but the angle itself, theta plus pi by 4. Okay, minus theta cancels. I have only pi by 4 left inside the bracket, and outside we have tan. This is 1. Tan pi by 4 is 1. Option A. Option is A. I hope this makes sense to all of you. Okay, once the session is done, once I have done, because I have told you very clearly, if you let me know what is your requirement, since all of you are joining right now, I'm trying to get to know you all. So based upon what is the requirement, I can make more improvement in the classes. So if you interact with me in a way, if you let me know in the comment sections, even though this is a recorded session, if you let me know, the last time one of you asked me, can we have a session, sir, where we learn all of this together? Done that. Same, let me know in the comment section. Sine of 2 sine inverse of 0.8. Theta you take. Sine inverse of 0.8 is sine theta is 0.8. We just learned cos theta is root of 1 minus sine square theta. Root of 1 minus 0.8 square root of 1 minus 0.64. How much is that? 0.36. So cos theta is 0.6. Cos theta is 0.6. Calculation is done. What are they asking? Sine of 2 theta. Formula we know? Yes, sir. Two into 0.8, 2 into 48, so 0.48. Again multiply this, 0.96. Now many of you might be thinking, sir, we have an alternative way to remember this. You just taught it right now. Sine of 2 sine inverse of x. Basically, I have taught you today only 2 sine inverse of x formula. Sine, what is that formula? Sine inverse of 2x into 1 minus x square. I'll show you. Here. 1 second. Here. 2 sine inverse of x is nothing but sine inverse of 2x into 1 minus x square. 1 minus x square. So we can use the same formula directly and get the result. No problem. No problem at all. But if you don't remember this formula, the alternative method I have taught you. But if you do remember, good luck, no problem whatsoever with that. What did I tell you? The formula you can use directly over here also. One second, let me just highlight it for you. Formula will be 2, not 2, sine inverse of 2x root of 1 minus x square. Check this out. We have what this value as? We can solve it from here. 2 into this value we can put. Right? 2 into x is what? 0.8. Okay. Over here you'll have 1 minus 0.8 square. That's nothing but if you solve it, you're going to get the same value. You'll have 2 into 0.8 into 0.6 multiplied. Okay. And this sine inverse and this sine will cancel each other. So answer gets back to the same thing. This is your method number 2. Here, right? This is your last question for the day. Let's solve this and conclude our class today. So sine inverse of 2 root 2 by 3, sine inverse of 1 by 3. Difficult? Not also. Check here. If I take this as theta, it means sine theta is, sir, 2 root 2 by 3. Correct? Right angle triangle, this is theta. Sorry, not theta, of course, not theta. Let me tell you. This is 90 degree, this is theta, right? So it means this is 2 root 2 and this is 3. This will become what? This will become square of 3 is 9. Square of 2 root 2 is how much? 4 into 2, that's 8. This value is root 1 equals to 1. This value is coming as equal to 1. This is sine theta. Can we write cos theta now? Yes, we can. 1 by 3. 1 by 3. I'm getting here. Cos theta is 1 by 3. Theta is cos inverse of 1 by 3. Now replace this theta by that value. You'll have cos inverse of 1 by 3 plus sine inverse of 1 by 3 is nothing but pi by 2. Option. So should we solve all of this? No. Why would you solve? You can see this is forming that Pythagoras theorem condition, right? 1, 3 and 2 root 2 is not up in numbers, in the natural numbers, but it is going to be forming a sides of right angle triangle. 1, 3 and 2 root 2. This is clear. Now this is the end of the lecture today in this class. Thank you all for joining this session, and I hope you found this helpful. I have done theory revision, I have done graphical part, domain range, nature of function, formulas, questions on those formulas. I have done board level questions, CET level questions, PYQs, all in this class only. So go through it, revise it, watch this session more and more, so that to get the more clarity regarding the concepts and questions. So if you have anything else to ask me, put that in the comment section, and I hope all of you are using the platform provided to you. That is all in one platform, AIO platform. It'll come for the ACE batch for free. There's no charge for that. Simply check the video's description down on the YouTube. You'll find join the course here. Then you click on that and you get to the, I have shown you how to get the, the platform, login, everything. Okay, but still if you have any doubts, any concerns, let us know in the comment section. We will resolve that very quickly. That's all in this class. See you in the next one. Till then, take care of yourself. Bye-bye.